Hello all, this is the second video for the game project using p5.js. We're going to be working on a game of DinoRunner next. Now DinoRunner is the game that happens when you have no connectivity in Chrome, you press space, and a dino starts running. Now I have a more expanded version on my YouTube channel with the same game done in processing, but today I'm going to have a look at how to accomplish a similar thing with JavaScript syntax. Now, this won't have any images. These you'll have to come up with if you look at my bonus video that will be posted later. For now, we're going to start out by making a new project with template.zip from the PowerSchool page. I will open this up, rename the folder to DinoRunner, and I'm going to rename my template.html to index.html as listed in the project requirements. When I open up index.html, I get this page, which is blank, but we can edit the CSS, we can edit the canvas. This canvas comes from JavaScript, this styling comes from CSS. Let's open this in Sublime Text, and you'll see that right now we have a simple template. You'll want to rename this, update comments, and edit title. If you want to include instructions, they can go into the body. For example, we have instructions up top and the canvas down below. Now, I'm going to delete this. You will notice that we have a list of files here that we can use or that are necessary for our program to run. Notice if I were to delete this and refresh, nothing would appear on the page. Now, if we want to include other files, which we will be doing here, we'll need to list them in our, quote, table of contents, unquote, which is this page. We'll simply say that we want to include another file, perhaps called Dinosaur, and maybe we'll want to include another file called Cactus, spelled correctly, and perhaps you'd also want to include a bird or another type of creature. I'm going to leave that for you to do. Now, let's go and get started. I'll go to my JavaScript folder and I'll open up template.js. Template.js being the place where our game logic is going to run. So I'm going to change the background. We'll keep the background white, but it's going to go in our draw method. Remember, this is where the game is at, as they say, or where the game logic should go. Now, for our purposes, we're going to need a dinosaur, and perhaps we'll need some cactuses. Cactuses possibly being the proper plural, as I doubt the word comes from the Latin. Let's see what we can do to start out our game. Right now we have a blank game. We're going to want to start out by saying that, let's say we have some score that increases with time. Indeed, I believe DinoRunner increases the score based on how long you stay alive. So we'll say we'll have some sort of score. We'll set it to 0. And then we're going to be changing the score based on time. So the way we can track, one simple way to track time, not the only way to track time, but one way that we'll be tracking it here is based on the number of frames that occur. If you want to increase the score by one point per frame, we can say if frame count percent 60 is 0, meaning if we have hit some number of frames that's divisible by 60, then score should increase. And to display a score, we can simply say that we want a text size of, say, 20. Then we want to place the text of the score at a location, and the location will be at, let's say, the upper right-hand corner of the screen. So width of the page, which is currently 500, minus 50, let's say minus 100, and then the height should be perhaps 40. Okay, and notice that if I refresh the page, nothing happens. We get not a number. Okay. So, because we declared this as a variable up here, we want to make sure that it's the same variable, which means that we don't need the word var more than once. So we see we start at 0, and it will increase forever. Note that if I change the size of the canvas to 1,000, which makes some sense, we get the score in the relative same place related to the right side of the screen, because I've talked about the width minus 100 being the location. Let's try width minus 50. That'll make it a little better to see. If you want to change the rate of score accumulation, just change this to, say, 30, or even 5, where your score looks like it goes up faster, which maybe makes the player feel a little better about themselves when they're playing your difficult game. So let's now see how we can make the other elements of our game. One way we can do that is by making some files to represent a dinosaur and to represent our cactus. So we're going to make a new file. We're going to save it as a dinosaur. And notice we're saving it into the DinoRunner folder under the JS folder. We'll save it as dinosaur.js. Then we're going to make a new file, and we're going to call it cactus. Apparently that's a hard word to spell, cactus.js. Now, what are we going to have in our game? We're going to have probably a var dino for our dinosaur, and we'll maybe want a var cactus, or cact for the cactus. And we'll say that dino is new dinosaur, and cact is a new cactus. So this is going to be an issue. If we refresh the page, nothing appears, and the reason for that is because we haven't yet defined what a dinosaur is, or what a cactus is. So we have to go into our game, or our files, and make those definitions. Let's start with a dinosaur and comment out our cactus. So a dinosaur is a relatively simple creature. We're going to first start making a constructor function. So we'll make a function called dinosaur. This function is essentially the definition of our dinosaur. It's going to tell us what information the dinosaur has and what functions the dinosaur has available to it. So we'll start out by saying that the dinosaur has an x value. And we'll start the dinosaur at the left side of the page, perhaps at x equals 50. This dot y, the y value, should maybe be somewhat above the bottom of the page, maybe at a position of the height of the page, and minus the height of the dinosaur. Now we haven't defined the height of the dinosaur yet, so we should do that. The width of the dinosaur might be 50, and this dot height, this dot h, is going to be, let's say, 100, a slightly taller dinosaur, maybe, let's say, 70. Now, the dinosaur is not going to have much else, although it might be convenient to think about what happens when the dinosaur jumps. And one way to do that is to say that this dot vy is 0, this dot a equals 0. Or we can just simply say something like this dot jumping equals false. There are a few ways to go about this. Perhaps a equals 0 or the acceleration equals 0 is a little more convenient to think about to start out. So now let's talk about what functions are available to the dinosaur. Well, we want the dinosaur to be able to be shown. So we'll use the words this.show, the magic words, and we'll say that show is a function. Note that the keyword this means that show is a part of this being the idea of a dinosaur. So when I say this.w, I'm saying the dinosaur's width. When I'm saying this.x, I'm saying the dinosaur's x value. When I'm saying this.vy, I'm saying the dinosaur's vy value. When I'm talking about a variable that isn't part of dinosaur, it won't have the word this in front of it. Height, for example, comes from the page itself. It comes from an assignment from create canvas. As soon as we say create canvas, width, this variable, becomes 1,000, and height, this variable, becomes 500. They are not part of dinosaur, as we can see. Now, let's go to the show function and see what we can show the dinosaur as. To start out, we're going to show the dinosaur as a block. So how will we do that? We'll fill with a very lovely green color. Maybe it's a little browner. And we'll say that we want to make a rectangle. And the rectangle is going to be defined in the following order: the x value, the y value, the width, and the height of the rectangle. Well, the x value is simply the dinosaur's x value, this dot x, and the dinosaur's height value, this dot y, dinosaur's width, and the dinosaur's height. Now, let's say we want to see this in action. How are we going to do that? Well, we're going to go to template.js. We're going to say dino.show and see what happens. Dino being the new dinosaur that we created, coming from the variable at the top. Dinosaur, whenever we say new dinosaur, we are saying make a new one, an actual object, and store it in the variable. Now here we're saying dino, go inside and use its show method, show function. I refresh the page and I have my green dinosaur sitting on the bottom of the page. We also have, note, a green score because the fill maintains its state until the next time fill is used. If we want to use, to have a black text, we'll simply say fill 0, right above where we define the text. And then we'll have black text. Now let's work on making the dinosaur jump. In order for the dinosaur to jump, we should have some idea of what it means to jump. There are a few ways to get this done. I'm going to show one of the options that probably is a little conceptually easier. One of the things we can do is say that we want a key pressed method. So function key pressed, and we'll say if key code is 32, that's the space bar, dino.jump. Now what does jump do? Well, let's try to figure this out. What we can say is this.jump will do the following. It will set vy, this.vy, it'll set this.vy to some negative value. A negative value is an upward value. And we'll say it will be, negative 5. Then we'll say this dot a is equal to 0.1. So let's see how this will function. Well, in order to jump and have our velocity and acceleration work, we have to have a move function. The move function defines how the dinosaur moves. It belongs to the dinosaur because we're saying this. So how are we going to move? Well, this dot y is going to be increased by this dot vx, or vy, and this dot vy is going to be increased by this dot a. But we also want to make sure that if this dot y plus this dot height is greater than the height of the page, meaning the bottom of the dinosaur goes below the height of the page, then we want to say that this dot a equals 0 and this dot vy is equal to 0. This way we won't fall through the page. This is important. This is essentially saying, hey, when we jump, we'll change some values, but when we land, this is the condition for landing. When we land, we want to change them back. We also want to say that this dot y is equal to height minus this dot h. We want to reset the y value. And otherwise, nothing will happen. If we aren't at the bottom of the page, or below the bottom of the page, we won't be resetting values. So now we have a lot of stuff to test. Let's see if this stuff works. First, we want to see if the dino can move. Let's see what happens here. Right now, the dino is doing nothing. Let's set an initial value for the velocity to -1 and see if the move function works. It certainly does. It's being called. The dino is moving up, and it will move off the page. Let's reset that to 0 as a starting value. And let's try jumping. We press the spacebar, and the dino rises up with some initial velocity. The acceleration will drag that velocity down until the velocity is negative. In fact, the velocity will be -5 when the dino hits the ground. But when the dino hits the ground, everything will be stopped and it won't be able to jump anymore. Now, if we don't think this speed is fast enough, or if we think the acceleration is too slow, we can always change those values in our jump function. Maybe make -10, negative point, or in 0.5. Now, the problem is we can also multiple jump, which is useful for a game like Flappy Bird, but not so useful for DinoRunner. The way to remedy this is to put a condition on our key pressed. If key code is 32 and dino.vy is 0, if the dinosaur isn't already jumping, then we can't jump. Now, you can still game this system a little bit, but it's much harder to. You can game the system by pressing space exactly at the apex of the jump. If you want to modify this so that it's a little more convenient, what you might say is, if dino.a is 0, we can jump. So let's try again. This is not something you can get around. So you can only jump when you're on the ground. This is some interesting physics that you can play around with if you're so inclined. But now that we have this, we need to involve our cactus. Now, cactus needs to have a few features. The first is that it can move horizontally. The second is that once it goes off the page, we refresh the cactus. At the end of the video, I will show you a way to have multiple cactuses that randomly generate as they go off the page. But that's a little more advanced, and while you're welcome to do it, it's not something that I'm going to be really covering in heavy detail. You can also simply make a bunch, like a few different cactus variables that will accomplish the same goal. So for our purposes, we're going to say function cactus, because we're defining what a cactus is. And we're going to start by including our information and our functions. Now, note that the definition only falls between these braces. You should not put other stuff down here. It won't be a part of the cactus definition. Let us discuss our cactus. We'll have an x value, or first we'll have a width. We'll set that width to say a random value between 50 and 75. So we might have a long cactus. This is something you may have to adjust if the game is too hard. This .height, well, we'll have to make sure that it's not taller than the dinosaur can jump, but we'll make it a random value from 40, let's say from 20, say from 50 to 75, 60 to 80. And if this becomes an issue, let's say this is 30 to 50. If this becomes an issue, we can always make the dinosaur jump higher by making the velocity value a little higher. But for now, let's keep it at 10. So this is something that you can control the difficulty of your game with. If you have a random value for your cactus's width and height, the cactus will always be a little different depending on which version, when it generates and which game you're gonna, how lucky you are. We'll also say that this .x is going to start off the page. We're going to say it's going to be at the width plus some random value to make sure we don't know exactly where it's going to be. That random value may range from 0 to about, let's say, 100. This way, our cactus will always appear on this side of the page when it starts. the y value is simply going to be the height minus this.h. The same as for the dinosaur. Finally, one thing that we can do is we can say this.vy equals some random value. Let's not set it to a random value. Let's set it to a specific value. This value you might decide to change based on the difficulty. You might decide to change it as the time increases. But you might be able to say that this.vy will start it at, or not vx. This.vx is going to be a negative value because we're moving to the left. We'll say it's a negative 10. Finally, let's draw this cactus with this.show. We'll define what drawing it means. And we'll say fill with maybe a brighter green. Let's say a 0, 255, 0. Let's make it a terrible green color. This is a great, let's make it sort of brownish. And we'll make it a little redder brown. And we'll say rect this.x, this.y, this.width, this.height. Now, let's see if our cactus, well, and we'll have a move method. So this.move equals function. And we'll say this.x plus equals this.dx. A standard move function. Now, the only problem is what happens when we go off the page, but we'll work on that in a moment. Let's go back to our template and uncomment our cactus creation. We'll make a new cactus, store it in cact, and then we'll say cact.show and cact.move. Refresh the page, and we see already that we have some issues. It's possible that we may just barely be able to get over the cactus, although it is randomly generated. You can see that each time it's slightly different. Oh, just barely. Now, what we can do is, when it goes off the page, we recycle it so it jumps back over here and then continues on. Let's see what that looks like. We'll say if this.x plus this.w is less than 0, this is our reset condition. This.reset. But now we need a reset function. We'll say this.reset is equal to function. We could call this respawn, we could call it reset. Let's call it respawn. So we'll respawn this cactus by saying that we want all of this stuff to be new. And we'll just be generating another cactus that's slightly different when we go off the page. Let's see what this looks like. So each cactus that comes across the page is slightly different. And obviously, this is extreme amounts of fun. If you want to make this more exciting, you'll make a bird class, and it will come in and swoop down from above. Now, the one thing that we're missing is an end to this game. Well, when does DinoRunner end? DinoRunner ends when we hit something. And the way we hit something is, well, we have to collide with it, and we have to tell the computer that we've collided with it. So what is one thing we have to pay attention to? We know that the front edge of the dinosaur, or the bottom edge of the dinosaur, can't touch the cactus. In fact, they can't be touching in any way, shape, or form. So one trick that we can do is we can say, hey, let's pay attention to when they're not touching, and then say they collide when they're doing the opposite of that. So let's do that right now. I'm going to say that I care about the cactus colliding with the ball. Or not the ball, the dinosaur. We'll say in here that the function can take in a variable. So what does this look like from our template? Well, every time we run through draw, we want to see if the cactus collides with the dino. If the cactus collides with the dino, the game is over. One way to do this is to say, hey, pay attention to the dino, and plug it into my collide function and see what happens. So collide will say that, hey, we'll say dino left, just for convenience, is the dino.x value. We'll say that the dino right is the dino x value plus the dino width. Dino top, dino y, and dino bottom is dino.y plus dino.h. And in this way, we can easily write a sort of if statement that checks to see whether the dino is colliding with the cactus. This is effectively the exact same method you want to use if you have a bird. So what we'll say is what we first want to know is when is the dino not colliding with the cactus. And you can draw this out on paper, but the way we would say this is something like if the dino left is greater than this dot x plus this dot width, the right side of the cactus. We also know we're not colliding when the dino right is less than this dot x. We also know we're not colliding when the dino top is less than this dot y plus this dot h, though this won't really happen in the case of DinoRunner. And we also know that if dino bottom is greater than this dot y, the cactus's y value, we're not colliding. This is when we're not colliding. Now there's a trick we can use when we're programming to say that we want a double negative. So when are we colliding? Well, when this isn't the case. The way we'll do that is we'll wrap it in parentheses and we'll put an exclamation point in front. The exclamation point says the thing to the right, this entire statement, is not true. So if this whole thing is not true, well, we've collided. And what happens? Well, we want to give some sort of information. One thing that we can say is that we want to give back a value of true. We've collided. Otherwise, we give a value of false. Another way of thinking about this is, hey, let's remove that double negative. And we'll say, hey, we're not colliding. So we'll say false, and we'll say true otherwise. When the dino is not colliding, we give back false. When the dino is colliding, we give back true. True and false are values that we can have in programming, and they're called Boolean values. True and false are really useful. Let's see how we can use this in our game. We can say, if the cactus collides with the dino, game over. Well, the problem is, this isn't quite useful for us. We want to go, in fact, with something a little bit like this. Let's have a their game over value and set it to false. And then, every time the game runs, we'll say game over is equal to whether the cactus dot collides with the dino. And then we want to say, if game over is false, then we do all this stuff. We show the dino, we show the cactus, we show everything. Everything works. We count up scores, and we check for collisions. But if game over is true, we want to say, in the big center of the screen, game over. You lose. And then we'll say that's going to be in the center of the page. Oh, well, let's put it a third of the way down. And then it's going to be in the middle of the page, and then we're going to make it big. Let's see what happens. Right now I'm jumping. We're all good. And we failed. So, after some troubleshooting, a quick look at Cactus shows that we have a little bit of an issue. And the issue comes in simply with this inequality. I switched the signs here from greater than to less than. And there was one other issue where the value we got in here, D, should be D here as well, because we're referring to the thing we're comparing to. But before I had it as dino. So quick bug fixing resolved that. Note, I return false if I'm not colliding with the dino. This should be a question mark. And then true when I am colliding with the dino. And let's see what happens. Oh, I missed. Game's over. I only got a score of 19. That's a shame. I'll refresh the page and I'll jump. And then I failed. Okay, great. So there are a few things you can do to improve this. One is adding in birds. One is adding in some way to reset the game. For example, when you click, maybe you want to set game over to equal true, and you want to reset all the values of everything. That's something that's pretty important. For example, you might say here, cac.respawn. And that would ensure that if you were to press click, somehow the game would continue without the cactus directly on you. Another thing you might want to do is have several cactuses. You might have a cact1 and a cact2. And then you do something similar where you'd have down here cact2.show, cact2.move, game over, so one way to do this would be to say, or cact2.collide. And this will give you, with Dino, and this will give you a value that says, hey, whether either one of them collide will tell me if the game is over. There's another way to do this with arrays. I'll do an array video later on. For that, let's see how this goes. One last thing over here, maybe you'll say cact2.x equals 1300. And we're missing one issue. We have one issue with this. Cact1, cact1. And I lost. And we'll refresh. And that's an impossible game. So you'd modify this so that perhaps you don't lose as quickly as I do. But this would ensure that you have things popping up. And by changing the variables in Cactus and changing the variables in Dinosaur, you'll be able to customize this game more easily. Great. Thank you for joining me.